All right, guys, your essential question is how do we approximate the area of a figure in a plane? Your vocabulary is sigma notation and upper and lower sums. Now, from elementary school and middle school, you found how to find the area of certain geometric shapes like rectangles, squares, triangles, and circles. For example, if you wanted to find the area of this rectangle, you would multiply 2 times 6, you get 12. Same thing over here, you'd multiply 12 times 1, you get 12. So you know how to find the area of simple geometric shapes, such as this, such as rectangles. However, what if I ask you to find the area of a non-geometric shape? So what if I wanted you to find this, this shape? Unfortunately, without calculus, you wouldn't be able to find the exact area of this shape, but you could approximate it using rectangles. One way you could do so would be to divide this interval into subintervals, and then you could form rectangles on those subintervals. So, for example, you could end up with something like that. And then that could help you approximate what the area of the shape is. Now, now this obviously wouldn't include, this actually is below the actual area of the shape. So this would be what we call inscribed rectangles, because the rectangles are inside the shape, and this answer is always going to be lower than the actual answer. The difference is if you have circumscribed rectangles, that's when the rectangles would be outside of the shape. So that would look something like this. And see in green, that would actually be more than the actual area. But one way that we can find an interval of the true area is to do the inscribed rectangles and compare that with the circumscribed rectangles, and then that would be your range. Because you'd have a low number and a high number, so your area would be somewhere between those two numbers. For example, let's say that I wanted you to find the area using just the lower sums of this shape on the interval from 0 to 2. Well, lower sums would be the inscribed rectangles. It's going to be a lower approximation of the true area. An upper would be the circumscribed rectangles, and that would be more. So if I wanted to draw rectangles on the inside of this shape, then I noticed that I would go up at 2/5 and draw over, and so there's one rectangle, and do the same thing here, and then do the same thing here, and here, and there. And so these would be my inscribed rectangles. And even though this wouldn't be an exact answer for the area, it would sure enough be close to it. So what I would do is I noticed that the width of each one of these intervals is 2/5. It's the same width. So the width of each rectangle is 2/5. To find the area of each rectangle, I have to find the height of it. Well, the height would be the value of the function at each one of these x values. So I'd want to find f of 2/5, f of 4/5, f of 6/5, f of 8/5, and f of 10/5. So I'd want to find the value at each one of those x coordinates. And then once you have those y values, then you can multiply each one of those by 2/5, and then you would get the area of each rectangle. And then finally, you would add up all the areas, and that would be your approximation. So let me take a second, and I'm going to find these values for each one of these functions. All right, so here are the values of those points for the function. Again, those are the heights. So what I'm going to do is I'm going to multiply each one of these by the width. So I'm going to multiply by 2/5 for each one. And so I'm going to take a second and see what those values are going to give me. All right, so here are all the values of each individual area. And I don't know why I put 2/5 there. That should be 0.4. And so now I'm just going to add up all of these areas together, and then that would give me my approximate answer. So this would be, and this is the sigma notation, that means sum, that means add up. So that would be 6.48. And so then that would be the lower approximation for those. I could compare that to an upper approximation, which would be more. And so then my answer, my true answer, would be somewhere between those two numbers.